A very good evening to all of you. Hello and welcome to another session of rTECHulate. And this session will be done by Mr. Uresh Dassanayake, the tech lead of Axiata Digital Labs, tech lead at Axiata Digital Labs. And he'll be doing about design patterns in real life. So to start off this session, we would like to invite the head of the department, the head of the computer science department of the Faculty of Science at University of Ruhuna, Madam Dr. J.A. Jeevani, to welcome all the participants, the guest speaker, and the organizing committee. Madam, over to you.
Yeah. Thank you. Good afternoon, everybody. I'm happy to see online most of our students, especially I welcome all of you, especially I welcome our resource person, Uresh Dassanayake. I think this is a kind of, we had series of technical sessions, and apart from that different guides, different workshops when the university is open. But now the situation is quite different. Even we didn't stop, our students are so much keen to continue these activities. So because of that, they have arranged, with the help of the department, a series of sessions. We had, I think, one session 2 weeks ago, as I can remember, and there are several guest talks and technical sessions we already organized in future. This is one of such event. So I'm very happy to welcome our resource person, Uresh Dassanayake, tech lead at Axiata Digital Lab. So I think you are not idle, because we all are working in ICT. I know you are very busy. Even in your busy schedule, you have allocated time to spend with our students. I appreciate that, because students are in quite different situation away from the university. Somehow we continue our lectures up to some extent and carrying out other works, always in touch with our students. So your contribution in this session also very much appreciate on behalf of the Department of Computer Science. So I think the students here can get a real chance to get exposed with the real experience which faced in the industry by an industry expert. So this is a very good opportunity for all of you. So I don't think, I don't need to take that much of time. So I invite Mr. Uresh Dassanayake to carry out this session. Thank you.
Thank you, madam. Let's begin the session now. So let's do an interactive session. Have you heard about design patterns? Design patterns. Hello. Yeah.
Yes,
Yeah. What are the design patterns you are familiar with?
Proxy, singleton.
Yeah.
Factory.
Yeah. Yeah. So, what is the design pattern? Why do we use a design pattern? So, to begin with, so what is a design pattern? So it's a design pattern is used for commonly occurring problem in software engineering, and it is generic and reusable solution, and it also supports. It doesn't violate any software principles. So like single responsibility, open close. There are the well-known software principle called solid software principle. So it doesn't violate any of that software principles. So that is why we use a design pattern. So what is single responsibility? Does anyone know? What is that principle? Single responsibility is like it is the one module is for one responsibility. So there can't be classes that does everything. Like Godfather classes, the software engineering doesn't allow Godfather classes. So single responsibilities, one class is responsible for one thing. So, and what is open clause principle? Have you heard about open clause principle? Hello? Just say no if you haven't heard. If you can't remember, just say can't remember. Hello.
In open clause, the functions should be open for use, but they should be closed for encapsulate for modification.
What it emphasizes in open clause principle, it says about classes. So a class is open for inheritance, but closed for modification. That is open clause principle. So likewise, there are several principles. So if you simply Google solid software principles, so every word S for single responsibility, O for open clause, and likewise they have you can go through the solid software principles. So in design patterns, we are mostly familiar with Gang of Four. Have you heard about Gang of Four design patterns? Hello. The Gang of Four design patterns. So, Gang of Four design patterns is it's a book done by four people, Gang of Four. So that's why it is called Gang of Four. So they have listed several design patterns under three pillars. So it is they have three pillars like creational design patterns. Under creational design patterns, they have factory method, abstract factory method, and etc. So and they have structural design patterns. It is decorator and proxy, and there are several design patterns under structural design patterns. And behavioral design patterns like observer, strategy, and likewise they have several behavioral design patterns. So it is the theory behind design patterns. So we'll go through a real world example. Have anyone been in industry? In the industry, does anyone have an industry experience, internships or whatever? Maybe not. So if you have when in the industry, you will receive a requirement document. In that requirement document, you will get all the requirements, screenshots, what to do, what not to do. Everything is listed in that requirement document. It's a contract between the company and the client. So in that contract, you will find screens like this. So this is the requirement. So we have when we log in, this is IoT dashboard. When we log in, we will be redirected to the IoT dashboard, and under that dashboard we have several widgets. So one widget is generator widget, and the other one is temperature widget. Likewise, there can be light widget, humidity widget, CO2 level widget. Likewise, there can be many widgets. So that is our dashboard. So under that dashboard, under a widget, we'll be showing the name, and under generator widget, we are showing the name and the fuel tank capacity fuel percentage and the meter RPM value, and whether the attached device to the generator is online or offline, and the time which the status was fetched, lastly fetched. So it's a time stamp. So that are the detail in widget. So dashboard is collection of widgets. So we have designed a dashboard. So how would we design this dashboard? It's very simple thing. There are several ways of designing dashboard. So there are bad ways and good ways. So to begin with, we'll go see what is the bad way of doing it. So bad way is we can fetch all the widget list, and with the HTTP module we can get with a simple get call, we can fetch all the widget list, and we can go through all the, with the for loop we can go through all the widget list, and under widget list if the given widget ID is mapped with temperature widget, we can draw the temperature widget. If the ID is matches with the generator widget ID, we can do generator widget modifications, coding under that. Likewise, we can continue. So does it what is what do we, why do we call it as a bad way? Anyone have idea why do we call it a bad way? So to begin with, I introduce you to software principles. One is single responsibility principle. Does this violate the single responsibility principle? Hello? Hello? Yes. Does this violate single responsibility principle? Can you hear me? Hello?
Yeah, we can hear.
Yes,
Yeah.
we can hear you.
Okay. Does this violate the single responsibility principle? It's a simple question. Yes or no question. What do you think?
If you
Just
guys can't talk, you can put your answer.
Just chat. What do you think? Hello.
Yeah,
Excuse me,
it
sir.
violates.
Can you repeat the question, please?
Huh?
Can you repeat the question, please?
Question. Do you want me to repeat the question?
Yes, sir.
Yeah. This is the example class to create the dashboard, IoT dashboard. What we are trying to do is in this we are creating a dashboard, IoT dashboard. Under that dashboard we have several widgets like generator widget, temperature widget. There can be many like CO2 measurements, humidity measurements. Likewise, there can be many widgets under the dashboard. So we are talking ways of doing it. So to begin with, we started with the bad way of doing it. So in the bad way, we are getting all the widget list with the API call, and we are going through all the API widgets given from that API, and under that with the if else conditions, we are generating all the widgets in the dashboard. So it is a one way of doing it. It serves the purpose, but we are not doing so. I am asking, does this, to begin with, I introduce you two principles. One is open close principle and the other one is single responsibility principle. So does this violate single responsibility principle? Hello. Hello. Am I clear to you?
Yeah.
Yeah. Okay. Do you understand the question? I am simply asking, does this violate this single responsibility principle? Hello. Hello. Just it's a yes or no question. Just say yes or no. What do you say?
Yes.
Yes. Why do you say so? Yeah, it is because single responsibility means if it is temperature widget, it should act as a temperature widget. So if it is generator widget, it should act as a generator widget. But in this class, it does everything. Temperature widget. If there is some else widget, it does everything. So this is violating single responsibility principle. So do you understand that? Hello.
Yes.
Yeah. So and the other one, open close principle. So what was open close principle?
It means that it can inherit, but it should be encapsulated for the outside world.
No, it can be inherit from the other classes, but it is extensible, but not closed for modification. That is open close principle. So in this case, this class is not inheriting any class. So, and also this is open for modification. If we got another requirement, for example, we have say in the long run we got to create another widget. So we have to come and edit this if else and create that widget. So this is not closed for modification. So this is open for modification. So this violate open close principle. Likewise, this violate every principle in solid architecture. So this is a bad way of doing it. Doing the IoT dashboard. So what is a good way? So we can simply think of a design pattern which serves our purpose. So what are the three types of design patterns introduced in Gang of Four design pattern? Does anyone remember? Hello.
Behavioral structure
and creational.
creation.
So yeah. So behavioral, structural, and creational. So in this case, what we are going to do is we are going to create widgets, create objects. So to create objects, we need a pattern. So what would you choose? where would our desired pattern would lie?
Creational.
Creational. So it is a creational. It should be under creational design pattern, because we are going to create object. So we are going to create widget. So it should be under creational design pattern. Under creational design pattern, there are many design patterns. So under creational category, there are many design patterns. So to create objects, there are two types of patterns called factory pattern and abstract factory pattern. Are you familiar with factory pattern? Hello.
Much.
Yeah, not much. Okay. So factory pattern and abstract factory pattern. So both are used to create objects. So in this case, what is the difference between factory and abstract factory? Factory creates object where in which the class inherits from one interface. Did you understand? Factory pattern is used for example, there can be there can be cars interface. Sorry, there can be a vehicle interface. Under vehicle interface, there can be concrete implement. There can be classes inherit that vehicle interface called cars, bus, van, likewise. So with the factory pattern, we can create objects with only with one interface. But in abstract factory, there should be more than to create objects with more than one interface. We should use abstract factory. So in our example, what we are going to do is we are going to create widgets. So every widget is inherited from one widget interface. So we will be using factory pattern. So this is the design for our solution. So what I did here is I brought you a requirement, and I talked with you how to analyze that requirement and how to come up with a design. So this is the design. So in this design, we have temperature widget component, generator widget component. Both components are inherited from widget interface. It has get status and on destroy method. So this is Angular, so web application. So in this case, we need on destroy of the class. We have to delete all the subscriptions and delete all the subscription and do other things. We have on destroy a life cycle hook. It's a life cycle hook. You can life cycle hook. You can Google it and read for more. So this is what I want to emphasize is this widgets component are inherited from one interface. So this is the factory implementation. In that factory implementation, factory implementation class has create component method. Under this is the concrete implementation. This is sample code for create component. It passes widget ID, and we have widget type map. So it is listed here, widget type map. It's a map it has integer and a class. This class is temperature widget component, and likewise there can be integer, and it's a map. One integer is mapped to temperature widget component, and the other integer is mapped to generator widget component. Likewise, it's a map. So from that map, we are getting a widget class, and with a Angular factory, we are creating that widget and returning that widget. And with a separate class, we can inject that to a view model. So this is how it is done. So this is a simple requirement how to design an IoT dashboard. And we talked about bad ways and choosing a pattern and a design. So if we had several widget types, like here we are showing the status. What if we had action widgets, like switch on light, switch on generator, and what if we have mix of widgets like action widgets and showcase widgets? Then we will have a separate interface widget, and there can be classes inheriting that widget. So the widget factory will use that action widget also. So that is abstract factory pattern. That is the difference between factory pattern and abstract factory pattern. I think you understood what I said. Is it great to you, or did you get something out of it? Hello.
Yes, sir. We understood it.
Okay. So this is our simple requirement one. So we'll talk about another requirement. This is another requirement. So in this requirement, so say we have already designed and programmed that application and given to the client. Now client comes to us saying there are, so let's go through the design again. What it does is every widget fetches the API detail. With the get status, we are fetching the widget status, widget list. So every widget call that. What happens here is there will be huge network calls, and server will get huge network traffic. So client will experience, after we are delivering this design solution, so they will come back to us with another requirement. So requirement is problem is increase the number of network calls are too much. So server can't handle that. So we have a requirement, reduce the number of API calls so that load on server will be low. So when fetching details from a server, there are two ways. One is polling, and the other one is a socket, web socket. In this case, we are using a polling mechanism. So each widget polls the data. The other one is socket. Socket is like polling is like this. Every 3 minutes we go to the server and fetch get the data. In socket, what it does is when there's a data, the server will give it to the front-end application. So that is the difference between polling and socket. So in our case, we are doing a poll. So with the poll, every time, after every 3 minutes, we are fetching data from the server. So did you get the problem? Hello. Hello. Yeah.
Uresh, can we go through it again?
Yeah. So I'll go through it again. Here, what it happens is this is the current implementation. So every widget go to the server and get data, and so that there will be a huge network call, the huge traffic on the network, the server. So that would be a problem. So do you understand the problem? No.
Yeah.
Yeah. So this is the current implementation now. So for a solution, what can we do? What would be the solution for this? So so we are going to do change the behavior of the widget. So that network calls should be reduced. So what would be the design, in which category which category will have the solution for us? What do you say? What do you think?
Behavioral one.
Behavioral one, yeah. So it is the behavioral one. Reduce the API calls. We are changing the behavior of the widget. So there are several behavioral design patterns like observer, strategy, and there are so many. So so design idea is we are assigning a one person to fetch HTTP calls, and once we get the data, we notify all the widgets. So to solve that, the design pattern is observable design pattern. In the components, inside the observable design patterns is observer and a subject. There are widget, there are classes which inherits the observer, and subject is observer is a component of a subject. So likewise, this is the design. So in this design, how it solves the problem is what it does is it notify all the widgets with the result. So what is the result we have? I'll take a big diagram. So can you see the diagram?
Yes.
Yeah. So so I'll explain this diagram. In this diagram, what it does is we have a widget holder. This is the intermediate person. What we have now. What I explained, we are in the earlier side. We are taking an intermediate person. This is the intermediate person, widget holder. So widget holder is responsible for fetching the data from with a HTTP call. So this is the fetching part. Widget service dot get list, and widget service got get widget status. This is the fetching part with the HTTP call. And when creating temperature component, we are passing the subject. We are passing a subject. So widget holder has a subject. When we create a widget with the widget factory, we are passing a subject. So when we notify, what it does is the subject will have a list of observables created here, and it will update all the observables. So inside the update method, we have the subject state. It's a subject state. Subject state is a device response. This is a generic class. This is the state. It's a state is type of device response. It's a topic. It's a topic. So it will get the state and update the view according to the state. So this is how it is implemented. So I think you might have understood the solution and design. So to overcome this, actually in web technology, there are several methods. In Java also, we have observable pattern implementation. Pattern implementation in Java, and in Angular also we have, with the RxJS support, we have subject observable implementation, where this is the implementation from the sketch. We can otherwise we can use existing library and serve this purpose. And also we without the design pattern also we can do this. We have service worker in web. Service worker, it caches. It also has it also can serve this purpose. So go to them as well, the service worker rTECH library. So they are widely used in industry nowadays. So I hope you got this, or how we are doing. I tried to simplify the design patterns, how it is implemented, but I don't know whether you get it or not. How do you feel? Hello. Hello.
Since it's the first time about the implementation, and we don't have much about experience about implementations, a little bit hard to understand, but
yeah,
it was manageable.
Yeah, but I'll pass you the presentation, the designs and sample code implementation is there. Try to go through and understand. So these are the things you will be doing in when you come to the industry. So you are in no man's land if you are not if you didn't have this knowledge when you are coming to the industry. So any questions? Hello. Hello. Does anyone have a question? Actually, when I was asked to do a session to a university students, the reason what I chose design patterns and implementations is when I go to interviews, I see there I feel that the people when passing out from the university doesn't have this experience. So you need this experience, otherwise you can't go with the industry, compete with the industry clients and all. You can't it's very hard to code without these patterns and software best practices. That's why I wanted to do this kind of session, and at least you should hear these kind of things are there, so you should learn. So that was my intention doing this session. So do anyone have any questions?
Actually, is thank you for doing this session on this how to use this design patterns in real life. So I just want to say that we are having finally a project now. So I think it's really good to have some knowledge in how to use these kind of design patterns in our application. So everyone should do a project and need to have some understanding. I think what are as per your thinking, what are the areas we should more concerned on that in terms of doing a final year project, also with regard to the design patterns?
When you comes to designing a project, the thing is the difference in university projects and industrial project is we maintain the project in industry, but in university final year project you don't maintain a project. So in that case you are not tend to do with best practices. It is there even in our era also. When we do the final year projects, we didn't know anything, and we have to research by ourselves, and we have to, without any industrial experience, it's very hard to think that way. But you should go through research papers, and there are many design patterns. For example, this is gang of 4 design patterns, and there are other design patterns like there are in front end side there are JavaScript anti pattern, sandbox pattern, and MVC is a design pattern. It is widely used in industry now. MVC pattern, model view controller. Spring is a framework with MVC design pattern. So there are many. So when you do a project, there are many frameworks. Try to use some framework and understand how it is implemented. For example, rather using observable the framework that implemented observable design pattern, try to understand what is under there. So you will then you will get a good idea how to use it, where to use it, when to use it, rather than using a framework. I mean, blindly using a framework. Try to understand what is under it. And when you are doing a project, try to implement software best practices. So for that you have to read so much, and yeah, that's it.
Thank you.
Maybe you can ask from the industry people. So maybe you might have senior people who are in industry. You can ask from them what would be the appropriate design patterns, and what are the drawbacks in your designs, and improve your design. So that's a way of doing your final year project. I think that answered your question.
Yes, thank you very much.
Okay. Any questions regarding the session? Anything you didn't understand? Hello.
So, is there any questions, anyone, before winding up the session? Okay, so it seems like we are done for the day, and thank you very much, Mr. Uresh, for taking your valuable time, for spending your valuable time with us, and educating us with your knowledge. Thank you very much. And before winding up, I would like to thank the organizing committee for organizing this, the organizing committee of the Computer Science Students Community of the University of Ruhuna, and the Department of Computer Science headed by Dr. J. Jeevani, for always backing us, and to all the participants who took their time off and participated. I hope you all were educated today during this session. So be in touch with us. We'll be coming up with another session probably the next Saturday, another valuable session just like this from a professional, just like Mr. Uresh. So be in touch with us. We are on Facebook, Twitter, Instagram. Do follow us. And the recording of this session will be uploaded on our YouTube channel. So please be tuned with our social media handles for those updates. So let's meet on the next session, which will probably happen the next Saturday. So until then, stay safe and stay home. Thank you very much.
Okay, so let's wind up this. Thank you. Thank you for this opportunity. Hope you got something from my session.
Thank you very much.
Yeah.
Thank you, Mr. Uresh.
Thank you.